Welcome back now to another exciting episode from the world of algebra. So today or tonight, this evening, we're looking at solving systems of equations by substitution. We've already looked at solving them by graphing, so now we're going to look at solving them by substitution. And remember, solving a system, we are looking for the places where that they intersect, where they cross, if they do. So just a quick review here. Remember, we said that there are two types. We have consistent and inconsistent systems. Consistent systems, that means that they intersect, okay? They intersect. Inconsistent systems do not intersect. So they do not intersect. Remember, inconsistent systems, these are ones that are parallel. We can tell that they are parallel because they have the same slope. They have the same slope, the same constant rate of change, the same rise over run, the same change in y over change in x's. They are parallel, so parallel lines. And the other ones we said are skew. Skew lines exist on two different planes, so we're not going to worry about that now. It's something for geometry, but I want to make sure that you understand that's the other situation. Lines could be skew. They could exist on a different dimension, a different plane. Now, consistent systems, the ones that intersect, they are either independent, that is one solution, that is 99% of all lines, or they are dependent. That means they have an infinite solution. Infinite solution, remember, those are the ones that it's the same line. It's the same line, usually written in a couple different ways or whatever. So we're going to look at solving systems by substitution. Now, the first thing that we have to look at when we're going to solve this system, we've got a system. Here, we've got two equations. We've got y equals 2x plus 1 and 3x plus y equals negative 9. Now, unlike graphing, they don't have to be written in slope-intercept form. But in order to solve a system by substitution, one of them has to be written as y equals or x equals. We need one of them to be written like y equals or x equals. And do we have that here? Yes, we do. Notice this first one right here. It says y equals. It is in y equals form. That means that is the one we are going to substitute in. Now, substitution works just like it does in any sport, any activity, in a class. Substitute means we're going to pull somebody out and put someone in. In this case, who are we pulling out? We're going to pull out this y. We've got a y right here. We know that what y equals. So we know right here y equals this out here. So we're going to come down here, and in place of this y, we're going to make a substitution. So we're going to take this equation, this 3x, what was plus y, okay, it did say plus y. What we're going to do is we're going to pull out y, and we're going to put in, who is y equal to? Well, y equals 2x plus 1. We're going to put them in place, equals negative 9. So that's substitution. You've been doing this now for a couple of years in classes, so now all we're going to do is we're going to solve for it. Look, only one variable. We've only got one variable now, so it's pretty easy. So now we're going to combine like terms. We're going to solve for this variable. So 3x's plus 2x's, that means we've got 5x plus 1 now equals negative 9. Okay, so we want to eliminate this plus 1, so we subtract 1 from both sides. We now have 5x equals, now we have negative 9 minus 1, negative 10. We have 5 times x, so we're going to divide by 5. And we find that x equals negative 2. X equals negative 2. That says that in our solution, we know right now that our x value is going to be, oops, my pen's not wanting to write. The x is negative 2. We don't know what the y is yet, but guess what? We're fixing to find out. Because in substitution, once we find one thing, guess what? We're going to take it up here and we're going to substitute it in. I'm going to pick the y equals because it's an easier one. So let's see. We're going to take y equals 2x plus 1. And we now know that x is negative 2, so we're going to put, in place of x, we're going to put negative 2. So what's 2 times negative 2? Well, we now have y equals negative 4 plus 1. Well, negative 4 plus 1, that means y equals negative 3. There's the y value, negative 3. We just solved that system by substitution. That means that if we were to graph it, we were to look at this, we would find that these two lines intersect at negative 2, negative 3. Okay. So let's try another one. Here again, first rule, remember, one of them has to be y equals or x equals. Do we have it? Yes, we do. So right here, we're going to take this, and we're going to put it right here in place of this y. So let's see, we've got 5x plus 3 times y. But we're pulling out y, and we're putting 4x minus 6 in its place equals -1. So if you need to pause that and look and see and make sure it makes sense, go for it. If not, we're going to keep going. So right now I got this little bit, I got 3 times y here, so I've got to do a little distributive property right here. A little distributing. Sorry here, I don't know what's happening with my pen, but little distributive properties. We'll take care of that. So let's see, 5x plus 3 times 4x. So that's 12x minus 3 times 6 is, so we've got minus 18 equals -1. So let's combine like terms. 5x plus 12x, well that's 17x minus 18 equals -1. Add 18 to both sides. So now we have 17x equals, well, 17. Divide by 17. We find that x equals 1. So x equals 1. So we know in our solution, I'm going to write it down here this time, x is 1. There's our solution set. We know the x is 1. We don't know what y is yet, but we're going to find out. You know how? We're going to plug this back in because we know that x equals 1. So now let's see. Y equals 4 times x. Well, x is 1 minus 6. 4 times 1 is 4. 4 minus 6. So y equals -2. So there we go. There's my solution. 1, -2. So I've solved that by substitution now. So by substituting in, we've solved this. So let's take a look at another one now. Okay, so remember, first rule is they need to be, one of them needs to be in y equals or x equals. Oh, they're not. So that means I'm going to have to write one of these in y equals or x equals. Now, so look at your two equations, and you need to decide which one would be easiest to get in that form. Now, I'm going to choose the top one. You could choose any of them. I choose the top one because this one is just as an x by itself. I'm not going to have to deal with a 2y, the 2y, or 3x or 4y. Now, does it matter whether you solve for x or y? No, it doesn't. But, so let's see. Let's start with x plus 2y equals 6. I need it to say x equals or y equals, so I'm going to subtract 2y. So now, notice I have x equals -2y plus 6. So I now have x equals -2y plus 6. So that's what I'm going to use now. I'm going to substitute in place of x, I'm going to substitute this in right here. I'm going to substitute this guy right here in place of x right down here. So let's go. Let me change colors here so we can see it a little better. So I've got 3 times x. Well, x now is -2y plus 6 minus 4y equals 28. Okay, so a little distributive property here. 3 times -2y, -6y. 3 times 6 plus 18 minus 4y equals 28. All right. I don't know what's happening there with that color. Give me a second. Let me see if I think I averted that crisis. Think I've got this fixed now. So there we go, 28. So combine like terms. These two are the same. So we have a -10y plus 18 equals 28. Subtract 18. I'm trying to get this y by itself. -10y now equals -28. And, whoops, that's not -28. That's a positive 28. 28 minus 18 is 10. Divide both sides by -10. And I find that y equals -1. Okay, so y equals -1. So now I'm going to take this and I'm going to plug this back in. And I'm going to plug it back in up here at this top up here. I'm going to plug it in this first one just because it looks easier. So let's see. You can plug it in any of them. It's not going to make a difference. So x equals -2 times y. But y is -1. -1. Oops. Plus 6. So -2 times -1. So I've got x equals 2 plus 6. Well, 2 plus 6 is 8. So x equals 8. So I now have my x value and my y value. X here is 8. Y is -1. So my solution is 8, -1. Okay, so there we go. We found another one. All right, so let's go one more try. All right, so we've got this one. Remember, first rule is, do we have an x equals or y equals? Yes, we do. So I'm going to take right here what y equals, plug it in right here, and let's go. So -6x plus 3, going to do distributive property in just a second. 2x minus 4 equals -12. So distributing, still got -6 plus 6x minus 12 equals -12. Okay, so let's go combine like terms. -6x plus 6x, that's 0 x's. They cancel out. Ooh, -12 equals -12. There's no variables. -12 equals -12. Well, that's a true statement. You want to go, yes, it is. Okay. Well, what has happened here is we have infinite solutions. Okay. We have infinite solutions. You know, we talked earlier and we said that in our systems, when we looked at them, that if we have a dependent system that is dependent and has an infinite number of solutions, you know, we said we have the same line. Sometimes they don't look like it. Well, look up here. Let's look at this. Let me take this -6x plus 3y equals -12. And let me show you this. What happens if we add 6x to both sides? Okay. So now we have 3y. Oh, it's going to write 3y equals 6x minus 12. Well, we're trying to solve for y equals. What if I divide everything by 3? So we now get y equals 2x minus 4. Oh, look at this. Same thing. They were the exact same equation. These two, what we have here is we have the same line. So that's when we have infinite number of solutions. So we say we have solutions. We've got an infinite number. So this is where we have that consistent system. But this consistent system is dependent. So we have a dependent system. So it's important there when we look at it, we got to solve them. All right, so that is solving by substitution. Hopefully not too difficult. Go on through this one and take a look at it. Make sure you got some good notes, and I will see you in class tomorrow.